Hello, dear friends, and welcome to the Bedtime Lab. It's so lovely to have you here, gently easing into a tranquil state as we explore the wondrous universe together. As you nestle in and prepare to drift off into a restful sleep, let me guide you through a journey of discovery about the search for extraterrestrial life. Our cosmos is vast and full of mysteries, and tonight we'll share some intriguing insights that might just tickle your imagination. Did you know that scientists estimate there could be as many as 100 billion galaxies in the observable universe? Each of these galaxies contains hundreds of billions of stars, and many of those stars are orbited by planets. It makes one wonder, doesn't it? Among all these countless worlds, could there be others like ours, teeming with life? Perhaps, somewhere out there, distant civilizations are pondering the same questions as we are. Speaking of which, let me share something interesting about our own Milky Way galaxy. It's believed that there are potentially 40 billion Earth-sized planets orbiting in the habitable zones of stars, where conditions might be just right for life. Imagine the possibilities: 40 billion chances for life as we know it, or perhaps life beyond our wildest dreams. Here's a fascinating fact. Scientists have discovered extremophiles right here on Earth, organisms that thrive in environments previously thought to be uninhabitable, like the crushing depths of the ocean or the scalding vents of volcanoes. These resilient life forms have broadened our understanding of where life might exist, hinting that life elsewhere might survive under similarly extreme conditions. And did you know that the famous Drake equation, crafted by the astronomer Frank Drake in 1964, aims to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way? It's an elegant formula made up of several variables, such as the rate of star formation and the fraction of planets that could support life. While the exact figures remain a mystery, the equation serves as a guiding light in our quest to understand our place in the universe. Speaking of equations, the search for extraterrestrial life also involves listening for signals from the stars. The search for extraterrestrial intelligence, or SETI, uses radio telescopes to scan the cosmos for signs of intelligent life. Imagine sitting by a radio, hoping to pick up a message from a civilization light years away. It's like a cosmic game of hide and seek, where the players may not even know of each other's existence. Let me tell you about a curious event known as the WOW signal. Detected in 1977 by the Big Ear Radio Telescope in Ohio, it was a strong, narrow-band radio signal that lasted 72 seconds. The signal's origin remains unexplained, and while it has never been detected again, it continues to tantalize researchers with the possibility of an extraterrestrial origin. This reminds me of a remarkable discovery closer to home. In 2020, scientists found phosphine gas in the atmosphere of Venus, a potential indicator of microbial life. Venus, with its scorching temperatures and acidic clouds, wasn't considered a likely candidate for life. Yet, this discovery has sparked renewed interest in our neighboring planet, showcasing how life might spring up in the most unexpected places. And here's something fascinating. The Kepler Space Telescope, launched in 2009, opened our eyes to a universe full of exoplanets. Over its mission, Kepler discovered more than 2,600 planets beyond our solar system, forever changing our understanding of the galaxy and highlighting the potential for life beyond Earth. Can you imagine a planet where it rains diamonds? That's not just a fantasy. Scientists hypothesize that on Uranus and Neptune, the intense pressure could cause carbon to crystallize into diamonds, and these brilliant stones might rain down through the planet's icy atmospheres. If such marvels can exist in our own solar system, who knows what wonders await in the vast universe? Speaking of wonders, consider the possibility of rogue planets, worlds that drift through space without orbiting a star. These lonely travelers might still harbor life insulated by thick atmospheres or subsurface oceans warmed by internal heat. The universe is full of surprises, and rogue planets remind us of the countless ways life might adapt to its environment. Here's a gentle invitation for you. As we continue our exploration, why not share where you're from in the comments? It's always delightful to see where our friends are tuning in from around the globe, as we all share this beautiful night sky together. As the stars twinkle above, let's allow our minds to wander and dream of all the possibilities that await us in the cosmos. And remember, the journey is just as enchanting as the destination. So, as we drift deeper into this cosmic lullaby, let's savor each moment and let the universe cradle us into a peaceful slumber. Let me tell you something truly intriguing about the search for life beyond Earth. Did you know that water, essential for life as we know it, is more common in the universe than we once thought? Water vapor has been detected in the atmospheres of several exoplanets, which stirs the imagination about the possibilities for life elsewhere. Speaking of water, Europa, one of Jupiter's moons, is believed to have a vast ocean beneath its icy surface. This hidden sea might contain more than twice the amount of water found on Earth, and scientists are eager to explore its depths for signs of life. Now, here's a fascinating tidbit. Titan, Saturn's largest moon, has lakes and rivers, not of water, but of liquid methane and ethane. Despite the frigid temperatures, some researchers speculate that life could exist in these alien seas, utilizing chemistry completely different from that on Earth. Imagine the diversity of life forms that might exist under such unusual conditions. And did you know that some scientists suggest looking for life not just on planets but on moons as well? Many giant planets host numerous moons, some of which may have conditions suitable for life. This expands our search, offering more places to explore and more chances to find life beyond our planet. Speaking of expanding horizons, the James Webb Space Telescope, launched in 2021, is designed to study the atmospheres of distant exoplanets, searching for chemical signatures that might hint at biological activity. With its advanced technology, it opens new windows into the universe, allowing us to peer deeper and clearer than ever before. Here's something to ponder. Artificial structures like Dyson spheres capture the imagination of those searching for advanced civilizations. These hypothetical megastructures could be built around stars to harness their energy, and their discovery could point to highly developed extraterrestrial societies. The idea challenges us to think beyond our current technological capabilities and imagine what might be possible in the far reaches of space. And what if I told you that the very building blocks of life, like amino acids and nucleotides, might have formed in the cold depths of interstellar space? Scientists have discovered complex organic molecules in nebulae, suggesting that the ingredients for life might be scattered throughout the universe, waiting to seed new worlds. This cosmic recipe for life hints at the potential for life to arise independently in numerous places. Consider this. In 1976, the Viking landers conducted experiments on the surface of Mars in search of microbial life. While the results were inconclusive, the mission sparked debates that continue to this day. Recent missions, like the Perseverance rover, aim to uncover more clues about past or present life on the Red Planet, making Mars a focal point in our quest for extraterrestrial life. Now let's think about the mysterious signals known as fast radio bursts. These are brief, intense bursts of radio waves originating from distant galaxies. While their cause is still unknown, some speculate they could be artificial in origin, sparking curiosity and encouraging further investigation into these enigmatic phenomena. Speaking of radio waves, did you know that in 2004, a series of unusual radio signals was detected by the Parkes Radio Telescope in Australia? Initially thought to be from space, these signals were eventually traced back to a microwave oven in a nearby kitchen. This amusing incident highlights the challenges in distinguishing potential extraterrestrial messages from earthly interference. And here's a thought-provoking question. Could life exist in the clouds of gas giants like Jupiter and Saturn? Some scientists have theorized that life forms might drift in the upper atmospheres of these massive planets, surviving on energy from the sun and nutrients carried by atmospheric currents. This notion invites us to expand our understanding of where life might flourish, looking beyond the surface of planets to their gaseous surroundings. Have you ever considered the possibility of life based on silicon rather than carbon? While carbon is the backbone of life on Earth, silicon shares similar chemical properties and could potentially form the basis of life in environments vastly different from our own. This concept challenges our assumptions and encourages us to consider unfamiliar life forms that might be out there, waiting to be discovered. And speaking of discoveries, the potential for life within our own solar system doesn't stop at Mars or Europa. There are intriguing possibilities on Ganymede, another of Jupiter's moons, where a subsurface ocean might exist beneath a thick ice shell. The more we learn about these celestial bodies, the more we realize the potential for life right in our cosmic backyard. Lastly, let's ponder the possibility of communicating with extraterrestrial civilizations. The idea of sending messages into space, known as active SETI, is controversial, with some scientists warning of potential risks. While we've sent messages like the Arecibo message in 1974, the debate continues about whether we should actively reach out or simply listen. This ongoing discussion reminds us of the delicate balance between curiosity and caution as we continue our search for life beyond Earth. As we delve deeper into these mysteries, let your mind wander through the vastness of space, where each fact we uncover adds another layer to the incredible tapestry of our universe. In this serene moment, allow the wonders of the cosmos to envelop you, guiding you softly into dreams that stretch across the stars. Let me share something intriguing with you. The search for extraterrestrial life extends beyond just scanning the skies. Scientists have also turned their attention to the depths of our own oceans, studying extremophiles, organisms that thrive in extreme conditions. These resilient life forms, capable of surviving in boiling hot springs or under immense pressure miles below the sea, offer clues about the potential for life in harsh environments elsewhere in the universe. Isn't it fascinating to think that our oceans could serve as analogues for alien worlds? Here's another captivating thought: the tardigrade, often referred to as the water bear. These tiny creatures can survive in the vacuum of space, enduring radiation levels that would be lethal to most life forms. Imagine the implications if similar organisms exist on other planets, capable of withstanding the harsh conditions of space travel or surviving on inhospitable planets. The existence of such life forms challenges our understanding of life's limits. Did you know that Venus, often considered Earth's evil twin due to its scorching surface and toxic atmosphere, might have hosted life in its past? Some scientists hypothesize that Venus once had oceans and a more temperate climate before a runaway greenhouse effect transformed it into the hostile environment we see today. The possibility that life could have once flourished there adds a layer of mystery to this enigmatic planet. Speaking of planets with potential pasts, Mars isn't the only celestial body where we're searching for ancient signs of life. Vesta, one of the largest asteroids in our solar system, shows signs of water alteration in its surface minerals. This suggests that Vesta might have had liquid water at some point, providing another intriguing target in our quest to understand the history of life in our solar system. It's amazing to think that even asteroids could hold secrets about life's origins, and here's something you might find surprising. Scientists are exploring the idea of shadow biospheres. These hypothetical biospheres on Earth might be home to life forms with biochemistry so different from our own that we haven't recognized them as living organisms. Such a discovery would revolutionize our understanding of biology and suggest that life could take on forms we've never before imagined. Let's talk about the fascinating world of exoplanets. With thousands discovered in recent years, some of these distant worlds have been labeled as super-Earths. These planets, larger than Earth but smaller than Neptune, offer tantalizing possibilities for habitability. Their rocky surfaces and potential for atmospheres make them prime candidates in the search for life. Can you imagine what unique forms life might take on these distant cousins of our planet? Imagine, too, the potential for life beneath the icy crust of Enceladus, another of Saturn's moons. Geysers on its surface spew water vapor into space, hinting at a subsurface ocean warmed by geothermal activity. Such an environment could be a haven for life, protected from the harsh conditions of space by a thick layer of ice. The thought of life thriving in underground oceans is truly captivating, isn't it? Speaking of hidden oceans, did you know that researchers are exploring the idea of life existing in the subsurface of Mars? Beneath its barren, rusty surface, there might be aquifers of liquid water warmed by geothermal heat. If life exists there, it could be similar to the microbes that eke out a living in the darkness of Earth's caves and deep-sea vents. Now, let's ponder the intriguing possibility of life on exomoons. As our technology improves, we're beginning to detect moons orbiting exoplanets, just as there are moons around the planets in our solar system. These exomoons could have conditions suitable for life, offering yet another avenue in our search for extraterrestrial life. The diversity of environments where life might exist is truly astounding. Have you ever considered the idea of planets orbiting pulsars? These rapidly rotating neutron stars emit beams of radiation and were some of the first places where exoplanets were discovered. Although the environment around a pulsar is harsh, with intense radiation, the discovery of planets in such unlikely places keeps the door open to the possibility that life could, against the odds, find a way to thrive even there. And here's a thought-provoking notion. Scientists are contemplating the potential of artificial life forms in the universe. If an advanced civilization has developed the capability to create life from scratch, they might seed other planets with these engineered organisms. This concept pushes the boundaries of how we define life and who or what might inhabit the cosmos. Speaking of life beyond our planet, consider the idea of microbial hitchhikers. As spacecraft travel through space, they might inadvertently carry Earth microbes to other celestial bodies. This possibility raises questions about planetary protection and the ethics of potentially contaminating other worlds with life from Earth. Such discussions remind us of our responsibility as explorers of the universe. And finally, let's explore the concept of panspermia, the hypothesis that life might spread through the universe via comets and asteroids. These celestial bodies could act as carriers, transporting life from one planet to another. If this process occurred, it might mean that life on Earth and elsewhere shares a common origin, linking us to other worlds in ways we've yet to fully understand. Imagine the cosmic connections that bind us to the stars. As you drift into a restful slumber, let your thoughts wander to these distant worlds and the infinite possibilities they hold. Each fact we uncover not only expands our understanding, but also deepens the mystery of our place in the universe. Embrace this gentle exploration of the unknown, and let it guide you softly into dreams filled with wonder and discovery. Here's an intriguing idea: the concept of life existing in environments dominated by silicon rather than carbon. While carbon is the backbone of life on Earth, silicon-based life could theoretically exist under different conditions. Silicon is akin to carbon in its ability to form complex molecules, which might allow for life forms that thrive in worlds vastly different from our own. Can you imagine creatures with silicon-based biochemistries living on planets with environments we would find inhospitable? This possibility stretches our imagination and challenges our preconceived notions of life. Did you know that some scientists are looking into the potential of life existing in the atmosphere of Jupiter? The gas giant's upper atmosphere contains the right temperatures and pressures for microbial life to possibly exist. These hypothetical microbes could float in the clouds, feeding on the chemical energy available and drifting through the vast, turbulent skies. The idea of life suspended in the atmosphere of such a massive planet is truly captivating, don't you think? Let's consider the environment of Titan, Saturn's largest moon. This fascinating moon has lakes of liquid methane and ethane on its surface, in addition to a thick atmosphere rich in nitrogen. Although it's frigid, some researchers speculate that life might adapt to using methane as a solvent instead of water. If life exists on Titan, it could be unlike anything we've ever encountered. Imagining methane-based life in such an alien landscape invites us to view the possibilities of life through a different lens. Speaking of peculiar environments, Europa, one of Jupiter's moons, is thought to harbor a subsurface ocean beneath its icy crust. Scientists are excited about the potential for life in this hidden ocean, which could be warmed by hydrothermal vents on the ocean floor. These vents might provide the energy and nutrients needed for life to flourish. The idea that Europa's icy crust hides an entire ocean teeming with life is both mesmerizing and mysterious. Have you ever pondered the possibility of life on planets orbiting red dwarf stars? These small, cool stars are the most common type of star in our galaxy and have long lifespans, potentially allowing life abundant time to develop. The habitable zones around red dwarfs are much closer to the star than Earth's distance from the Sun, but planets there could still support life if they have the right conditions. This expands the canvas of our search for extraterrestrial life considerably. Here's a thought-provoking notion: the idea of extremophiles existing not just on Earth, but throughout the cosmos. Extremophiles are organisms that thrive in extreme conditions, such as intense heat, high radiation, or extreme pressure. The existence of such life forms on Earth suggests that similar organisms might survive on other planets or moons with harsh environments. This discovery would redefine our understanding of life's resilience and adaptability. Did you know that some researchers are exploring how life might adapt to environments with little to no sunlight? On Earth, certain ecosystems rely on chemosynthesis rather than photosynthesis. Life forms in such environments derive energy from chemical reactions rather than sunlight. If similar ecosystems exist on other planets, it would broaden the range of potential habitats for life, highlighting the creative ways life can sustain itself. Let me tell you about the exciting search for biosignatures in the atmospheres of exoplanets. Scientists are developing technologies to detect gases like oxygen, methane, and carbon dioxide in the atmospheres of distant worlds. The presence of these gases in specific ratios might hint at biological processes, offering indirect evidence of life. The thought of detecting the faint chemical whispers of life from light years away is truly awe-inspiring. Speaking of detecting life, did you know that researchers are also looking for technosignatures, signs of advanced technological civilizations? These might include unusual patterns of light or radio waves, artificial structures orbiting stars, or even engineered changes in a planet's atmosphere. The search for technosignatures is a thrilling frontier that invites us to consider not only the existence of extraterrestrial life, but also the possibility of communicating with it. Imagine for a moment the idea of life existing in environments with exceptionally high pressures, such as the deep oceans of ice giants like Neptune or Uranus. While these planets are composed mainly of gas, their deep interiors might contain oceans of liquid water or ammonia, where high-pressure life forms could potentially thrive. This notion opens up a realm of possibilities for life in unexpected places. Here's something interesting: the role of cosmic radiation in the potential for extraterrestrial life. On Earth, cosmic rays can spur chemical reactions that might have been crucial to the origin of life. If similar processes occur on other planets, cosmic radiation could be a catalyst for the development of life, helping it to arise from otherwise unpromising beginnings. Did you know that the search for life also includes efforts to decode mysterious signals from space? While many signals turn out to be natural in origin, the search continues for those that might be artificial. The famous "wow" signal detected in 1977 remains one of the most tantalizing unexplained signals, fueling speculation about possible extraterrestrial origins. Let's also consider the intriguing idea of planetary migration and its implications for life. Planets can change orbits over time due to gravitational interactions, potentially moving in and out of the habitable zone. This dynamic process might allow life to emerge or be extinguished as planets shift positions, painting a complex picture of life's potential ebb and flow in the universe. Finally, let's touch on the captivating concept of galactic habitable zones. Just as there are habitable zones around stars, there might be regions within galaxies where conditions are more favorable for life. These zones could depend on factors like the density of stars, the presence of heavy elements, and the frequency of supernovae. Contemplating the possibility of galactic oases where life might flourish stretches our imagination across vast cosmic distances. As you settle in for a peaceful night's rest, let your mind wander through these diverse possibilities of life beyond Earth. Each fact we explore deepens the enigma of our universe and sparks our curiosity to learn more. Embrace these gentle mysteries as you drift into dreams of distant worlds and endless cosmic wonders. Consider the notion of panspermia, a hypothesis suggesting that life on Earth might have originated elsewhere in the universe. This idea posits that life, in the form of microbes, could travel across space on asteroids or comets, seeding planets with life. If true, it would mean that we might be descendants of interstellar travelers, with our origins tracing back to distant cosmic shores. Imagine how this expands our understanding of life's journey through the cosmos, linking us to other worlds through invisible threads. Here's a captivating thought. the possibility of silicon-based life forms. While life on Earth is carbon-based, some scientists speculate that silicon, which shares chemical properties with carbon, could form the backbone of life on other planets. Silicon-based life might thrive in environments vastly different from our own, perhaps with high temperatures or exotic atmospheres. Such life forms would challenge our assumptions about biology and open new avenues in the search for extraterrestrial life. Did you know that our search for life includes listening for fast radio bursts? These are mysterious, high-energy astrophysical phenomena that occur as brief, intense flashes of radio waves. Some researchers wonder if they could be signals from advanced civilizations. Although natural explanations are still being explored, the possibility of communication from distant worlds keeps our ears perked and imaginations alight with wonder. Consider the extraordinary notion of life on rogue planets, those drifting through space without a parent star. These nomadic worlds might still harbor life if they possess internal heat sources, such as geothermal activity, that keep their subsurface oceans warm. Imagine these lonely planets, adrift in the void, nurturing life in their hidden depths, isolated yet resilient in the face of cosmic solitude. Let me share something intriguing: the role of dark biospheres in the search for life. These are hypothetical ecosystems that exist in the darkness, far from any starlight, relying entirely on geothermal or chemical energy. On Earth, dark biospheres include deep ocean vents where life thrives without sunlight. If such environments exist elsewhere, they might support life in unexpected and overlooked corners of the universe. Have you ever considered the potential for life on exomoons? Just as moons orbit planets in our solar system, exomoons orbit exoplanets, and they too could be habitable. The gravitational interactions between an exomoon and its planet could generate heat, creating conditions suitable for life. This expands the list of potential habitats beyond planets to their often overlooked companions, adding layers to the cosmic tapestry of possible life. Did you know that scientists are exploring the concept of shadow biospheres? These are hypothetical forms of life that might exist alongside familiar life, but are fundamentally different in their biochemistry. Such life forms on Earth could have gone unnoticed by standard detection methods, leading researchers to wonder if similar shadow biospheres exist on other planets, offering an entirely new dimension to the search for life. Here's another fascinating idea: the use of quantum biology to understand life's origins. Quantum mechanics, usually associated with the behavior of subatomic particles, might play a role in biological processes such as photosynthesis or enzyme reactions. If quantum effects are crucial for life, they could influence where and how life develops elsewhere in the universe, intertwining the very small with the vastness of space. Speaking of intertwining, have you heard about the possibility of life harnessing magnetic fields? Some organisms on Earth use magnetic fields for navigation, and it's conceivable that extraterrestrial life might exploit magnetic fields for survival or communication. Such an adaptation would suggest that life can emerge and thrive under conditions we might not ordinarily consider, pointing to the versatility of life. Imagine the potential for life in the atmospheric layers of gas giants like Jupiter or Saturn. Although the surfaces of these planets are inhospitable, their upper atmospheres could provide the right conditions for life. Floating microorganisms might drift in the clouds, feeding on chemical compounds and sustained by the planet's energy sources. This notion invites us to look beyond solid surfaces and consider the rich possibilities within gaseous envelopes. Let's not forget about the intriguing studies of life under ice. On Earth, life persists beneath thick layers of ice in places like Antarctica. These environments, isolated from sunlight for millions of years, mirror conditions that might be found on icy moons or even on planets in other solar systems. If life can endure under such circumstances here, it raises hopes for similar resilience elsewhere. Consider the potential influence of cosmic dust. Tiny grains of dust drifting through space might carry organic compounds, contributing to the chemical complexity necessary for life. These interstellar travelers could deliver life's building blocks to planets, acting as seeds for the initial sparks of biochemistry. The idea that cosmic dust plays a role in life's cosmic dance adds another layer to our understanding of life's interconnectedness across the universe. And here's something to ponder: the concept of universal biology, which suggests that despite the vast diversity of potential life forms, there might be common principles that all life shares, driven by the laws of physics and chemistry. If true, this could guide our search for life by focusing on these universal traits, providing a more unified approach to understanding life's potential in the cosmos. As these thoughts weave together, they paint a picture of a universe filled with possibilities. Each fact invites us to stretch our imagination beyond what we know, embracing the unknown with a quiet sense of wonder. As you drift into restful slumber, let these gentle musings on extraterrestrial life accompany you into dreams of boundless discovery. Did you know that some scientists are considering the role of panspermia in the spread of life across the cosmos? This intriguing idea suggests that life might not have started independently on each planet, but could have been seeded by microorganisms hitching rides on comets, asteroids, or even spacecraft. Imagine tiny life forms, encapsulated and protected, traveling vast distances through space, arriving on new worlds to potentially spark the genesis of life. This concept blurs the line between origin and migration, offering an expansive view of how life might proliferate in the universe. Speaking of cosmic travelers, have you ever thought about the possibility of life existing in the clouds of Venus? Despite its harsh surface conditions, Venus has a temperate layer of atmosphere where the pressure and temperature are similar to Earth's surface. In this cloud layer, scientists have detected mysterious absorptions that hint at the presence of unknown chemical processes, which some speculate might be biological in nature. This unexpected potential makes Venus our closest planetary neighbor, a subject of renewed interest in the quest for life. Let me share something captivating about the search for extraterrestrial intelligence. The concept of technosignatures is emerging as a key area of study. Unlike biosignatures, which indicate biological processes, technosignatures are evidence of advanced technology such as artificial light, industrial pollution, or even directed energy signals. As our technology advances, we become more capable of detecting these subtle hints of intelligent life, broadening our search from simply looking for life to seeking civilizations. Have you considered the notion that life might thrive in the extreme environments of neutron stars? These incredibly dense remnants of supernovae have intense magnetic fields and bizarre surface conditions. Some researchers hypothesize that life forms could exist, adapted to such extreme environments, perhaps based on exotic chemistry or unknown physics. The idea challenges our understanding of life's limits and encourages us to keep an open mind about where life might exist. And here's an interesting fact about Mars. Recent studies suggest that liquid water might still flow intermittently on its surface. The discovery of recurring slope lineae, dark streaks that appear and disappear with the seasons, has fueled speculation about the presence of salty liquid water. If microbial life exists on Mars, these transient water flows could provide crucial habitats, reminding us that even the driest deserts might hold surprises. The search for extraterrestrial life also takes us deep below the surfaces of icy moons like Europa and Enceladus. These moons are believed to harbor vast subsurface oceans beneath their icy crusts, kept warm by tidal heating from their parent planets. Recent missions have even detected plumes of water vapor erupting from Enceladus, hinting at complex interactions below the surface. These hidden oceans might be some of the most promising places to find life, protected from the harsh conditions of space by their icy shells. Imagine the potential for life within the vast, dense atmospheres of brown dwarfs, which are often referred to as failed stars. These celestial objects are not massive enough to sustain nuclear fusion like stars, but they are not quite planets either. Some scientists theorize that their thick atmospheres could support life forms that utilize chemical energy. This idea expands our search to include a class of objects that blur the lines between planets and stars, revealing the complexity of cosmic habitats. Here's something to think about. Scientists are exploring the idea of life based on silicon rather than carbon. Carbon is well known for its ability to form complex molecules necessary for life as we know it, but silicon shares some similar chemical properties. If life elsewhere in the universe evolved using silicon as a building block, it could exist in environments hostile to carbon-based life, challenging our assumptions and expanding the horizon of what we consider possible. Speaking of alternative chemistries, the potential for life in methane lakes on Saturn's moon Titan is another fascinating avenue. Titan is unique with its thick atmosphere and surface lakes of liquid methane and ethane. While these conditions are vastly different from Earth's, they might support life forms that metabolize methane in ways similar to how life on Earth uses water. This notion invites us to imagine life thriving under conditions we might otherwise deem inhospitable. Consider the possibility of life on comets. These icy bodies travel through the solar system and beyond, carrying complex organic molecules. Some theories suggest that comets could serve as life incubators, with their interiors providing the necessary conditions for chemical reactions to take place. If life can emerge on such transient and dynamic objects, it would suggest that life is not only resilient, but also opportunistic, seizing any chance to take hold in the universe. Let me tell you about the exciting discovery of exoplanets in the habitable zones of their stars. These so-called Goldilocks planets are neither too hot nor too cold, potentially allowing liquid water to exist on their surfaces. With thousands of exoplanets identified, many in their star's habitable zone, the chances of finding life as we know it increase exponentially, reminding us just how vast and varied the cosmos can be. Did you know that some researchers propose the existence of life forms that might live in the upper atmospheres of stars? While this seems improbable, the idea is that life could exist in gaseous environments adapted to extreme conditions of heat and radiation. This radical notion forces us to rethink the environments we consider suitable for life, once again highlighting the diversity of possible life forms. And here's a curious thought. The influence of galactic tides, the gravitational forces exerted by the Milky Way, could potentially affect the development of life. These forces might influence the orbits of comets, or shape the structures of interstellar clouds, indirectly impacting the conditions necessary for life to emerge. This interconnection suggests that life on a planetary scale is not only a local phenomenon, but also a product of larger cosmic dynamics. Lastly, have you contemplated the idea that life might exist in a form we can't currently imagine or detect, perhaps as energy beings? Some theoretical models suggest that life could exist as patterns of energy or information, leaving no physical trace. This speculative idea challenges the very core of how we define life, encouraging us to consider possibilities beyond our physical and biological frameworks, inviting us to dream of the unimaginable. As you ponder these astonishing facts, let the limitless potential of the universe lull you into a gentle, restful slumber where dreams of exploration and discovery await. Let me share with you the intriguing concept of panspermia, the hypothesis that life can travel between planets and potentially seed life on them. Imagine microorganisms hitching a ride on meteorites, traveling vast distances through space and finding a new home in a hospitable environment. This notion suggests that life on Earth might have origins elsewhere in the cosmos, sparking a sense of connectivity across galaxies. Speaking of cosmic connections, did you know that some scientists are exploring the possibility of life existing in the atmospheres of rogue planets? These are planetary bodies that do not orbit a star, but drift through space on their own. Even without a nearby star, geothermal energy from within could sustain life, painting a picture of planets as self-contained ecosystems thriving against all odds in the cold depths of space. Here's something fascinating. The search for extraterrestrial life isn't limited to faraway planets and moons. Some researchers are investigating the potential for life in the atmosphere of Venus. Despite its harsh surface conditions, the upper layers of Venus's atmosphere are more temperate and could potentially harbor life. The discovery of phosphine gas, which on Earth is associated with biological processes, has led to renewed interest in this cloudy world, prompting us to look closer at our celestial neighbor. And here's a curious possibility. Life could exist in the dark, icy depths of Neptune's moon Triton. With a surface covered in nitrogen ice and geologically active with cryovolcanoes, Triton presents an intriguing scenario where life might thrive beneath its frozen exterior. The potential for a subsurface ocean, heated by geothermal activity, adds another layer of mystery to this distant moon, sparking imagination about the forms of life it might conceal. Can you imagine the potential for life around pulsars? These are highly magnetized, rotating neutron stars that emit beams of electromagnetic radiation. While the environment around pulsars is extreme, with intense radiation and magnetic fields, some propose that life might eke out an existence in niches shielded by strong magnetic fields. This idea stretches our understanding of life's adaptability, pushing the boundaries of where we might find living organisms. Here's an intriguing thought. Some scientists speculate about life existing in the expansive underground caverns of Mars. Beneath the planet's surface, protected from harsh surface conditions, these caverns could provide a stable environment for microbial life. The discovery of lava tubes and potential water reserves underground fuels this speculation, inviting us to consider the hidden worlds that might exist just beneath our feet on other planets. Speaking of hidden worlds, consider the potential for life in the subsurface oceans of Jupiter's moon Ganymede. As the largest moon in the solar system, Ganymede is believed to host a saltwater ocean beneath its icy crust. The presence of a magnetic field suggests a dynamic interior where tidal forces from Jupiter could provide the necessary energy to support life. This tantalizing possibility continues to captivate scientists, driving missions to uncover the secrets of this giant moon. Imagine the concept of life forms that thrive on radiation, absorbing it as a source of energy. Known as radiotrophic organisms, These hypothetical life forms would turn the harsh, radioactive environments found around certain stars or within asteroid fields into their home. By expanding our definition of what life could be, we unlock new avenues for exploration, reminding us of the resilience and adaptability of life. Have you ever considered the notion of life that uses sound waves as a means of communication or even sustenance? In environments where traditional chemical processes might be limited, such as dense gaseous planets, life forms could evolve to utilize vibrations and sound. This idea encourages us to broaden our perspectives on the senses and mechanisms life might employ, challenging our most fundamental assumptions. Let's explore the idea of biomimicry in the search for extraterrestrial life. Researchers are studying extremophiles, organisms that thrive in extreme conditions on Earth, to understand how life might survive in similar environments on other planets. This approach not only aids in the search for life beyond Earth, but also inspires innovations in technology and sustainability, bridging the gap between biology and space exploration. Here's a thought-provoking idea. The universe might be teeming with life, but it's in a form we don't recognize. Some scientists propose that life could exist as distributed networks of chemical reactions, lacking distinct physical entities like cells. Such a form of life would challenge not only our detection methods, but also our very understanding of biology. It invites us to rethink the parameters of life, venturing into realms of pure chemistry. Finally, consider the potential for artificial life forms, created through synthetic biology or advanced technology, to exist beyond Earth. These life forms, crafted by intelligent beings, could populate areas of space inhospitable to natural life. This concept blurs the lines between biology and technology, prompting us to ponder the future of life and our role in creating new forms. It reminds us that the search for extraterrestrial life isn't just about finding life, but also understanding what it means to be alive. As you drift into a peaceful slumber, let these wondrous possibilities of the universe fill your dreams with curiosity and wonder, inspiring visions of the extraordinary life forms that might be waiting to be discovered among the stars. Did you know that some scientists are exploring the potential for interstellar panspermia? This is the idea that life on Earth might have originated from microorganisms hitching a ride on meteoroids, comets, or even dust particles from space. These tiny travelers could survive the harsh conditions of space, eventually landing on our planet and sparking the beginnings of life. This concept not only suggests a cosmic connection to our origins, but also hints that life could be more widespread in the universe than we currently imagine. Another fascinating thought is the potential for life in the atmosphere of Saturn's moon, Titan. With its dense atmosphere rich in organic compounds and lakes of liquid methane and ethane, Titan presents a unique environment unlike any other in the solar system. Though it lacks water in the liquid form we're familiar with, some scientists propose that life could utilize these alternative liquids to thrive, raising intriguing questions about the adaptability of life. Here's something curious. The search for extraterrestrial life sometimes involves listening to the cosmic symphony of radio waves. The SETI, Search for Extraterrestrial Intelligence Institute, uses large radio telescopes to scan the skies for signals that might indicate intelligent life. By analyzing patterns and frequencies, scientists hope to detect messages from distant civilizations, offering us a chance to listen to the stars and perhaps hear a cosmic hello. Speaking of signals, did you know that some scientists are experimenting with sending messages from Earth into space, called METI, Messaging Extraterrestrial Intelligence? These messages, crafted with care, aim to introduce ourselves to any listening extraterrestrial civilizations. This endeavor not only invites us to think about how we represent humanity, but also challenges us to consider the consequences of announcing our presence to the cosmos. Imagine the possibility of life existing in environments dominated by superionic water. On planets or moons with high pressures, water could exist in a state that is neither solid nor liquid, but somewhere in between. This unusual state might support life forms adapted to such extreme conditions, broadening our understanding of where life could exist in the universe and what it might look like. Here's a surprising notion. Some researchers are considering the potential for life in the clouds of Jupiter. Although the planet's atmosphere is made up predominantly of hydrogen and helium, there are layers where temperatures and pressures are more Earth-like. In these regions, life forms could potentially float, using energy from the planet's abundant lightning storms or chemical reactions. This idea challenges us to envision life adapted to far different conditions than those on Earth. Have you ever pondered the idea of holographic life? It's a speculative concept that suggests some forms of existence might not have a physical presence as we understand it. Instead, they could inhabit a higher dimensional space, appearing as holograms in our three-dimensional world. This thought pushes the boundaries of our perception and understanding of life, inviting us to consider modes of existence beyond our current grasp. Another intriguing avenue is the study of bioluminescent life forms in the universe. On Earth, creatures like jellyfish and fireflies use bioluminescence for communication and survival. It's conceivable that extraterrestrial organisms might also harness light in creative ways, especially on planets with little sunlight or under thick atmospheric layers. These glowing beings would be a sight to behold, illuminating their world in a dance of lights. Consider the potential for intelligent life that communicates through quantum entanglement. This is a phenomenon where particles become interconnected in such a way that the state of one instantly influences the other, no matter the distance between them. If life forms have evolved to harness this property, it would redefine our understanding of communication, offering instantaneous connections across vast cosmic distances. What about life forms that thrive in environments with intense gravitational forces? Some scientists speculate that life might exist on massive planets where gravity is much stronger than on Earth. These life forms would need to evolve unique adaptations to withstand crushing pressure, offering us a glimpse into the incredible versatility and resilience of life. Another mind-boggling idea is the possibility of silicon-based life. On Earth, life is carbon-based, but in environments where carbon is scarce, silicon could serve as an alternative. With similar chemical properties, silicon-based life might develop in exotic ways, challenging our assumptions about the elemental building blocks of life. And then there's the notion of life that exists in temporal flux. Hypothetically, these life forms might experience time differently, perhaps perceiving centuries as moments or vice versa. This concept could redefine our understanding of consciousness and experience, inviting us to ponder the nature of time and its influence on living beings. Have you ever considered the potential for life in the atmospheres of gas giants like Uranus? Though the conditions are extreme, with high winds and volatile gases, there are layers where organic molecules could form. Life in such environments might drift on atmospheric currents, sustained by chemical reactions, offering a dynamic and ever-changing existence. Finally, think about the idea of life that thrives in shadowy regions of a planet, away from starlight or extreme temperatures. These shadow biospheres might rely on heat from the planet's core or chemical reactions instead of sunlight. This notion challenges our reliance on light as a life-giving force, expanding our horizons to encompass the darkness. As you let these thoughts guide you towards a restful sleep, may your dreams be filled with the wonders of the universe, the possibilities of life in its myriad forms, and the exhilarating quest to uncover its mysteries. In the vastness of the universe, the search for extraterrestrial life has inspired countless minds to explore and question. Have you ever wondered about the role of extremophiles in our quest? These remarkable organisms thrive in Earth's most inhospitable environments, such as acidic lakes and boiling hydrothermal vents. By studying them, scientists gain insights into the types of alien life forms that might exist on other worlds. It reminds us that life can be incredibly resilient and adaptable, capable of thriving in conditions once thought impossible. Speaking of inhospitable environments, did you know that Mars is home to the largest volcano in the solar system, Olympus Mons? This towering behemoth stands at about 13 miles high, nearly 3 times the height of Mount Everest. Some researchers believe that past volcanic activity on Mars could have created conditions suitable for life, perhaps by melting subsurface ice and providing essential nutrients and energy sources. Imagine discovering microscopic Martian life that once thrived in ancient volcanic hot springs. Here's another fascinating tidbit. The concept of panspermia suggests that life on Earth might have originated elsewhere in the universe. This theory proposes that life could travel between planets on meteorites or comets, potentially seeding planets with the building blocks of life. If panspermia holds true, then the life forms we see around us might share a cosmic ancestry with life elsewhere in the universe. Have you ever heard of the Drake equation? This is a formula developed by astronomer Frank Drake to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy. The equation incorporates factors such as the rate of star formation and the fraction of stars with planetary systems. Although it relies on many uncertain variables, the Drake equation sparks fascinating discussions about the likelihood of intelligent life beyond Earth. And here's something intriguing. Some scientists are exploring the idea of using artificial intelligence to sift through vast amounts of data collected in the search for extraterrestrial life. By training algorithms to recognize patterns and anomalies, researchers hope to uncover signals or phenomena that might otherwise go unnoticed. This approach could potentially accelerate discoveries, helping us find a cosmic needle in a galactic haystack. Have you considered the possibility of life beneath the icy crust of moons like Europa and Enceladus? These moons harbor subsurface oceans that might be kept warm by geothermal activity. Such environments could resemble Earth's deep ocean hydrothermal vents, where life flourishes in the absence of sunlight. The prospect of discovering alien life swimming in these dark, hidden oceans is both thrilling and humbling. Speaking of hidden life, did you know that some scientists speculate about the existence of shadow biospheres on Earth? These hypothetical ecosystems consist of microbes that use biochemistry fundamentally different from known life. If such organisms exist, they could provide clues about how life might arise and persist in conditions unlike those found on Earth, offering a glimpse into the diversity of life that could exist elsewhere. Here's a thought-provoking notion. The study of exoplanets has revealed a diverse array of worlds, including some in the habitable zone of their stars, where conditions might be right for liquid water. These discoveries suggest that potentially life-supporting planets are more common than previously thought, fueling hopes of finding worlds teeming with life. Have you ever imagined the potential for life on rogue planets? These enigmatic worlds drift through interstellar space, untethered to any star, Without a parent star, they might seem inhospitable, but internal heat generated by radioactive decay or tidal forces could provide energy for life. Discovering life on such a planet would challenge our understanding of the essential ingredients for habitability. Consider the paradox of the Fermi paradox, named after physicist Enrico Fermi. It highlights the contradiction between the high probability of extraterrestrial life and the lack of evidence for or contact with such civilizations. This enigmatic question invites us to ponder why, in a universe brimming with stars and planets, we have yet to encounter extraterrestrial life. Here's a surprising idea. Some researchers propose that dark matter, which makes up most of the universe's mass, could play a role in the evolution of life. If certain life forms have evolved to interact with or utilize dark matter, they might exist beyond our current detection capabilities, inhabiting a universe that's stranger than we can imagine. Another intriguing avenue is the study of techno-signatures, which are signs of advanced technology from extraterrestrial civilizations. These might include large-scale structures like Dyson spheres, which are hypothetical megastructures built around stars to harness their energy. By searching for these techno-signatures, scientists hope to find evidence of civilizations far more advanced than our own. Imagine the potential for life forms that communicate using neutrinos, subatomic particles that pass through matter almost without interaction. Neutrinos are notoriously difficult to detect, so life forms utilizing this method might remain hidden from us, communicating silently across the cosmic stage. Finally, consider the necessity of revisiting the assumptions that guide our search for extraterrestrial life. As we explore the universe, we might need to reassess what constitutes a habitable environment, what life might look like, and how it might communicate. This openness to the unknown is a fundamental part of the journey to discover life beyond Earth. As you ponder these possibilities, let your imagination drift among the stars, dreaming of the mysteries yet to be unraveled. Imagine for a moment the vastness of the universe, and within it, the relentless pursuit to find life beyond our planet. Did you know that Venus, often called Earth's twin due to its similar size and composition, has intrigued scientists with the possibility of life in its clouds? Despite its surface being inhospitable due to extreme heat, some researchers speculate that the cooler, cloud-filled atmosphere might harbor microbial life. The recent detection of phosphine, a gas that on Earth is associated with life processes, has fueled this speculation, suggesting the need for deeper exploration. Speaking of intriguing atmospheres, let me share something captivating about Titan. Titan is veiled in a thick, hazy atmosphere, rich in organic molecules, which are the building blocks of life. Its surface is dotted with lakes and rivers of liquid methane and ethane. This unique chemistry could provide a different pathway for life, challenging our Earth-centric view of habitability. Can you imagine life forms thriving in such an alien environment, using methane instead of water? Here's another thought-provoking fact. The discovery of extremophiles on Earth, organisms that thrive in conditions once thought too harsh for life, has expanded our understanding of where life might exist. From the boiling hot springs of Yellowstone to the frigid ice of Antarctica, these resilient creatures demonstrate life's incredible adaptability. This resilience bolsters the idea that life could exist in extraterrestrial environments once deemed uninhabitable. Have you ever heard about the concept of astrobiology? It's the study of life's potential in the universe, encompassing biology, chemistry, and astronomy. Astrobiologists investigate life's origins, evolution, distribution, and future. Their research not only guides the search for life beyond Earth, but also helps us understand the potential of life adapting to different planetary conditions. Isn't it fascinating thinking about the connections between life here and the potential for life elsewhere? Here's something you might find surprising: the potential role of artificial intelligence, AI, in the search for extraterrestrial life. By analyzing the vast amounts of data gathered from telescopes and space missions, AI can identify subtle patterns or anomalies that human analysts might miss. This technological partnership could dramatically increase our chances of detecting signs of extraterrestrial life. Imagine, too, that some scientists are exploring the idea of biosignatures as indicators of life. These are chemical and physical markers that might suggest biological processes. For instance, the presence of certain gases in an exoplanet's atmosphere, like oxygen or methane, could hint at biological activity. The challenge lies in distinguishing these biosignatures from non-biological processes, a puzzle that keeps researchers tirelessly engaged. Did you know that the search for life often focuses on water as a key ingredient? Water's unique properties make it an ideal solvent for life's chemistry. However, scientists are also considering other liquids, like ammonia or methane, as potential life-supporting solvents. This expands the range of environments where life might arise. Speaking of fresh perspectives, have you ever heard of the concept of cosmic pluralism? It's the philosophical idea that the universe is teeming with many worlds, some of which might host life. This notion dates back to ancient Greece and has influenced scientific thought throughout history. Today, with the discovery of thousands of exoplanets, cosmic pluralism feels more plausible than ever, inviting us to wonder about the diverse possibilities of life beyond Earth. Let's not forget about the fascinating technique known as radio astronomy, used to search for extraterrestrial intelligence. By listening for unusual radio signals from space, scientists hope to detect communications from intelligent civilizations. The famous "wow" signal, detected in 1977, remains one of the most tantalizing yet unexplained signals ever received, sparking endless curiosity and debate. And did you know that some researchers propose the concept of post-biological life? This idea suggests that advanced civilizations might transition from biological forms to digital or machine-based existence. Such entities could possess capabilities far beyond our imagination, potentially communicating or traveling across the cosmos in ways we have yet to comprehend. Consider the role of culture in shaping our search for extraterrestrial life. The stories and myths we tell often reflect our hopes and fears about encountering alien life. This cultural lens influences scientific inquiry, shaping the questions we ask and the methods we use to explore the cosmos. Can you see how our collective imagination guides the quest for discovery? Furthermore, the study of meteorites that have landed on Earth provides clues about the potential for life elsewhere. Some meteorites contain organic compounds, suggesting that the building blocks of life could be widespread in the universe. This raises intriguing questions about how life might begin on other worlds, seeded by cosmic debris. Lastly, think about the challenge of communicating with extraterrestrial civilizations. The vast distances between stars mean that any messages sent or received would take years, if not centuries, to travel. This time delay requires patience and persistence, underscoring the monumental scale of our endeavor. As you reflect on these surprising facts, let your mind wander through the cosmos, pondering the possibilities of life beyond our world. The universe is full of mysteries waiting to be uncovered, and who knows what tomorrow's discoveries will bring. Let me share something intriguing to begin with: the idea of panspermia, a hypothesis that life might travel across the universe on comets and asteroids. Imagine microorganisms hitching a ride through space, potentially seeding life on distant planets. This concept suggests that life on Earth could have originated elsewhere, carried here by cosmic travelers. Isn't it fascinating to think that life might not be confined to one planet, but could instead be a cosmic wanderer? Speaking of cosmic wanderers, did you know that the study of extremophiles on Earth provides valuable insights into this possibility? These organisms thrive in conditions that were once thought impossible for life, such as deep-sea hydrothermal vents or acidic lakes. Their existence expands our understanding of where life might thrive beyond our planet. If life can adapt to such extreme conditions here, who's to say it can't exist in similar environments elsewhere in the universe? Here's an intriguing thought. Some scientists are investigating the potential for life in the clouds of gas giants like Jupiter and Saturn. These planets, with their thick atmospheres and complex chemistry, might harbor life in ways we can't yet fully imagine. The idea is that life could exist as floating microbial life forms sustained by the chemical energy in the atmosphere. Can you envision such an existence drifting through the skies of a distant world carried by alien winds? The search for life isn't just about finding it, it's also about understanding how it might communicate. Did you know that some researchers are considering the possibility that extraterrestrial civilizations could use technologies or frequencies that we haven't even discovered yet? This means our current methods of listening and looking might only scratch the surface of potential communication channels. It's a humbling reminder that our technological reach is still limited, urging us to expand our horizons as we search the skies. Another surprising fact is the role of stellar nurseries in the search for life. These regions, where stars are born, are rich in organic molecules, the building blocks of life. The presence of complex organic compounds in these star-forming regions suggests that the ingredients for life are more widespread than we once thought. It's like a celestial kitchen where the recipe for life might be brewing on a cosmic scale. Let me tell you about an exciting development. Scientists are now considering the idea that life might exist in subsurface oceans on icy moons, such as Europa and Enceladus. Beneath their frozen surfaces, these moons are believed to house vast oceans of liquid water. The presence of geysers and the detection of organic molecules in ejected plumes make these moons tantalizing candidates for exploration. Could these hidden oceans be teeming with life, waiting for us to uncover their secrets? And then there's the concept of techno-signatures, indicators of advanced technology that could hint at the presence of intelligent extraterrestrial civilizations. Instead of searching for biological signs, scientists might look for evidence of technology, such as artificial light or waste heat. This approach broadens the scope of the search, offering new avenues to explore in our quest to discover intelligent life beyond Earth. Did you know that the process of terraforming, which is often discussed in the context of making other planets habitable for humans, could also provide clues about how life might adapt to alien environments? By studying how we might alter the atmosphere and surface of another planet, scientists gain insights into how life could evolve under different conditions. This reciprocal relationship between understanding our influence and imagining extraterrestrial adaptations enriches our view of life's potential diversity. Consider this. Some researchers propose that life might not be based on carbon as it is on Earth. Instead, it could be silicon-based or utilize entirely different chemical processes. This possibility pushes the boundaries of our understanding, encouraging scientists to think outside the box when searching for alien life forms. The universe is full of surprises, and life could manifest in ways we have yet to conceive. Another captivating idea is that life's signature might be found in the spectra of distant planets. By analyzing the light from these celestial bodies, scientists can detect the presence of certain gases and chemicals that might indicate biological activity. This method, known as spectroscopy, offers a non-invasive way to peer into the atmospheres of exoplanets, searching for signs of life from afar. And did you know that some theorists suggest that advanced civilizations might create megastructures, like Dyson spheres, to harness the energy of their stars? These massive constructions could potentially be detected by their unique energy signatures, providing another potential techno-signature for researchers to look for. It's a concept that stretches the imagination, illustrating how advanced intelligence might engineer solutions to cosmic challenges. Here's an intriguing notion: the role of intuition and creativity in scientific discovery. While data and analysis are fundamental, the leaps in understanding often require a creative spark or an intuitive leap. In the search for extraterrestrial life, this blend of rigorous science and open-minded creativity could be what ultimately leads us to make contact. Lastly, ponder the ethical considerations of discovering extraterrestrial life. How would such a discovery impact our view of humanity? And what responsibilities might we hold in interacting with alien civilizations? The profound implications of finding life beyond Earth remind us of the interconnectedness of all living things and the vastness of the universe we call home. As you drift into slumber, let your imagination soar across the stars, pondering the enigmatic wonders that await in the cosmic ocean. As we continue our gentle exploration through the cosmos, consider this curious notion, the concept of panspermia. It's a hypothesis suggesting that life might spread throughout the universe via comets, asteroids, or meteorites. Imagine life hitching a ride on these celestial travelers, potentially seeding planets with the building blocks necessary for life. This idea expands the possibilities of where life could originate, suggesting that perhaps Earth itself was once a recipient of such cosmic seeds. Speaking of cosmic travelers, did you know that some scientists are searching for life by studying the impact craters on Mars? These craters, formed by ancient collisions, may have once hosted lakes or seas, providing a protected environment where microbial life could have thrived. The sediments within these craters could hold clues to past life, preserving organic compounds or fossils in a Martian time capsule. Here's something fascinating. The search for life isn't limited to looking outward. We also consider the possibility of life existing in parallel dimensions or universes. This concept, known as the multiverse theory, suggests that there might be countless other universes, each with its own unique conditions and potentially its own forms of life. While purely theoretical for now, it challenges us to question the limits of our reality and what might lie beyond. Did you know that radio telescopes, like the ones used in the SETI program, are constantly scanning the skies for signs of intelligent life? These instruments listen for signals that could indicate communication from distant civilizations. While we've yet to receive a confirmed message, the ongoing search serves as a reminder of our persistent curiosity and hope that we're not alone in the universe. Another intriguing fact is the role of extremophiles, organisms that thrive in extreme environments, in the search for extraterrestrial life. These resilient creatures, found in places like the deep ocean vents and acidic hot springs on Earth. By studying extremophiles, scientists gain insight into how life might survive on other planets with harsh conditions. They're potential indicators of life, such as specific gases or substances that might signify biological activity. Scientists search for these signatures in the atmospheres of exoplanets using powerful telescopes and spectrometers. For example, the presence of oxygen or methane could suggest the existence of life processes similar to those on Earth. Here's an interesting thought. Some researchers are pondering the potential for life in the atmosphere of Venus. Despite its harsh surface conditions, Venus has a region in its clouds where temperatures and pressures are more Earth-like. This habitable zone raises the tantalizing possibility of microbial life existing high above the planet's surface, perhaps floating within its dense atmosphere. Imagine this: the possibility of finding life on rogue planets. These mysterious worlds drift through space, unbound to any star. While they lack the warmth of a sun, some scientists propose that geothermal energy or residual heat from their formation might sustain life in underground oceans. It's a reminder that life could exist in the most unexpected places, hidden in the dark recesses of the cosmos. Speaking of unexpected locations, there's also the idea that life might exist in the form of shadow biospheres here on Earth. These hypothetical forms of life would be so different from known life that they would have gone unnoticed, existing in parallel to the organisms we're familiar with. Discovering such a biosphere would revolutionize our understanding of biology and the diversity of life. Did you know that the study of life's chemical precursors can be traced back to the interstellar medium? This vast expanse between stars contains complex organic molecules, the same building blocks that are essential for life. By understanding the chemistry of these molecules, scientists gain insights into the potential for life to emerge in different parts of the galaxy. There's an exciting development in synthetic biology that could aid in the search for life beyond Earth. Scientists are designing artificial life forms, creating organisms with entirely new genetic codes. These synthetic life forms could be used to test the limits of life's adaptability, providing clues about how life might evolve in alien environments with different chemical compositions. Imagine the implications of finding technosignatures in the form of artificial satellites orbiting distant worlds. These would be unmistakable signs of advanced civilizations utilizing technology similar to our own. Detecting such signals would be a momentous discovery, signaling that we are not alone in harnessing the power of technology. And here's a thought-provoking possibility. The search for life in the universe might one day lead us to discover other forms of consciousness. While we typically search for signs of biological life, the concept of machine consciousness, sentient artificial intelligence, could redefine our understanding of life itself. Imagine encountering a civilization where machines have achieved a form of consciousness, offering a new perspective on intelligence and existence. Lastly, consider the potential for life to exist in the form of post-biological entities. As civilizations advance, they might transition from biological to technological existences, living within digital or artificial constructs. Such civilizations would leave behind detectable traces in the form of technosignatures, challenging us to recognize life that has transcended its biological origins. As you ponder these possibilities, let your imagination drift through the vast expanse of the universe, where the search for life is as much about finding answers as it is about embracing the mysteries that lie beyond our current understanding. Let me share something intriguing. Some scientists are exploring the possibility of life on Titan, Saturn's largest moon. Titan is unique because it possesses lakes and rivers of liquid methane and ethane, along with a thick atmosphere rich in organic compounds. While vastly different from Earth, these conditions could allow for entirely novel forms of life to develop, perhaps based on liquid hydrocarbons instead of water. Can you imagine such a world where life swims in seas of methane under an orange sky? Another captivating concept is the idea of panspermia, which suggests that life might spread throughout the cosmos by hitching rides on comets or meteorites. This means that life on Earth could have originated from microorganisms that traveled through space, surviving the harsh conditions of interstellar travel before seeding our planet. If panspermia proves true, it could imply that life is more common and interconnected across the universe than we currently believe. Here's a thought. The discovery of phosphine in the atmosphere of Venus has sparked debate among scientists about the potential for life. Phosphine is a gas that on Earth is typically associated with biological activity. The presence of this gas on Venus raises questions about microbial life existing in its clouds, offering a tantalizing hint that life might adapt to even the most inhospitable environments. Did you know that Europa, one of Jupiter's moons, is another prime candidate in the search for extraterrestrial life? With its icy surface and subsurface ocean heated by tidal forces, Europa presents a potential habitat for life. The possibility of hydrothermal vents on its ocean floor, similar to those on Earth, could provide the necessary energy and nutrients for life to thrive in its dark, hidden waters. Here's something you might find fascinating. The ancient philosophical debate about extraterrestrial life dates back to the Greek philosopher Epicurus. He posited that there were infinite worlds in the universe, each potentially harboring life. This notion was revolutionary for its time, suggesting that the cosmos was far more diverse and populated than previously thought. Speaking of ancient ideas, the search for life has deep roots in our own literary history. In the 19th century, the French writer Camille Flammarion penned La pluralité des mondes habités, a book that captivated readers with the possibility of life on other worlds. These early musings laid the groundwork for the scientific exploration of extraterrestrial life that we continue today. An exciting development in this field involves the use of artificial intelligence to analyze vast amounts of astronomical data. AI algorithms can sift through millions of signals from space, identifying patterns that might indicate the presence of extraterrestrial technology or communication. This cutting-edge approach enhances our ability to detect faint signals that could be lost in the cosmic noise. Here's a curious thought. Some scientists are considering the role of quantum biology in the evolution of life on other planets. Quantum effects might play a significant role in biological processes, influencing how life develops under different conditions. This emerging field could offer new insights into the fundamental nature of life and its potential variations across the universe. Did you know that the concept of the rare Earth hypothesis suggests that complex life might be exceedingly rare in the universe? This hypothesis posits that a unique combination of astrophysical and geological factors on Earth contributed to the development of complex life, making us exceptional rather than typical. It challenges us to consider the delicate balance of conditions required for life to flourish. Speaking of rarity, the idea of great filters is another intriguing aspect of this search. These are hypothetical barriers that prevent civilizations from advancing to a level capable of interstellar communication or travel. The Great Filter could lie in our past, making our emergence as a technological species exceedingly rare, or it could be ahead of us, posing existential challenges we have yet to face. Here's an interesting observation. The discovery of exoplanets in the habitable zones of their stars has expanded our understanding of potential life-bearing worlds. Known as the Goldilocks zone, This is the region where temperatures are just right for liquid water to exist. The proliferation of such discoveries has fueled excitement about finding Earth-like planets that could host life. Consider this: the development of new space telescopes, like the James Webb Space Telescope, promises to revolutionize our search for extraterrestrial life. These advanced instruments will allow us to peer deeper into the universe and analyze the atmospheres of exoplanets with unprecedented precision. By identifying biosignatures, we could uncover evidence of life far beyond our planet. And here's a surprising fact: some scientists are exploring the idea of life based on silicon rather than carbon. While carbon is the backbone of life as we know it, silicon could form complex molecules under different conditions. This alternative biochemistry could lead to the emergence of life forms unlike anything we have ever imagined. Lastly, ponder this possibility: the search for extraterrestrial life could ultimately lead to a deeper understanding of our own place in the universe. As we explore the cosmos, we're not only seeking other forms of life, but also gaining insight into the nature of life itself. This quest invites us to reflect on the interconnectedness of all living things and the mysteries that await us among the stars. As we drift through these thoughts, let them lull you into a state of wonder and curiosity about the universe's boundless possibilities. Each fact we uncover brings us closer to understanding the great cosmic tapestry of which we are all a part. Let me share something intriguing. The idea of terraforming other planets as a way to support human life has a surprising connection to our search for extraterrestrial life. By studying how we might alter a planet's environment to make it habitable, scientists gain insights into the conditions necessary for life to thrive elsewhere in the universe. This dual exploration of creating life-sustaining conditions and finding them naturally is a fascinating aspect of space science. Imagine this: the moons of Saturn, like Enceladus and Titan, are also on the radar for life seekers. Enceladus has geysers that shoot water ice into space, suggesting a subsurface ocean potentially hospitable to life. Titan, with its dense atmosphere and lakes of liquid methane, offers a whole new realm of possibilities for life forms that might be radically different from what we know. These moons remind us that life might not be restricted to planets alone. And here's something that might surprise you. The concept of biosignatures extends beyond gases like oxygen or methane. Scientists are now considering the technological signatures of extraterrestrial civilizations, often called technosignatures. This includes detecting unusual heat patterns that might indicate large structures or energy use on distant worlds. Our search for life, therefore, includes both the biological and the technological, a testament to the breadth of our curiosity. Speaking of curiosity, did you know that the search for life isn't solely focused on finding living organisms? Scientists are equally interested in the fossilized remains of past life. This is why Mars has been such a focal point for exploration. Its ancient riverbeds and dried-up lakes could hold clues to life forms that existed billions of years ago, offering a glimpse into the planet's biological history and evolution. Here's a thought-provoking idea. In addition to searching our own galaxy, scientists are also looking beyond it. The discovery of what are known as rogue planets, planets that do not orbit any star and drift through interstellar space, expands the scope of our search. These wandering worlds could potentially harbor life, free from the gravitational pull and radiation of a nearby star. It's a hauntingly beautiful notion, isn't it? Reflect on this. The Fermi paradox, a famous question in the search for extraterrestrial life, ponders why, Given the high probability of extraterrestrial civilizations, we have yet to encounter any. One proposed solution is the zoo hypothesis, suggesting that advanced extraterrestrial civilizations intentionally avoid contact with us, much like zookeepers observing animals in a zoo. This hypothesis invites us to consider our place in the cosmic scheme, encouraging a humbling perspective. Another interesting angle to consider is astrobiology's impact on our understanding of life's adaptability. The discovery of extremophiles, organisms that thrive in extreme environments on Earth, such as deep-sea vents or acidic hot springs, has broadened our definition of habitable zones. If life can exist in such harsh conditions here, it's tantalizing to imagine what might be possible on other worlds. Here's a lesser-known fact. The study of ancient Earth life holds secrets that could guide our extraterrestrial pursuits. Stromatolites, fossilized microbial mats from billions of years ago, provide insights into early life on our planet. By understanding how life began and evolved here, we can better identify similar signatures on other planets. Consider this. The search for extraterrestrial life has also influenced our understanding of time. The concept of the cosmic calendar, popularized by Carl Sagan, compresses the history of the universe into a single year. In this context, modern human existence occupies only the last few seconds of December 31st. This perspective highlights the vastness of time and space, reminding us of the infinite possibilities that lie beyond our current knowledge. Speaking of the infinite, have you ever pondered the notion of parallel universes? Some theories suggest that our universe might be just one of many, each with its own set of physical laws. In these other universes, life might take forms unimaginable to us, expanding the horizons of our search far beyond the boundaries of our own universe. Here's something you might find surprising. While we often focus on distant planets, Earth's own atmosphere holds secrets that could aid our quest. The study of atmospheric chemistry helps us understand how certain gases, like oxygen or methane, could be indicators of life processes. By mastering these techniques on Earth, we improve our ability to detect similar signs on planets light years away. Reflect for a moment on the role of art and culture in our search for life. Science fiction, in particular, has inspired countless scientists to pursue careers in astrobiology and astronomy. This genre not only entertains but also challenges us to think creatively about the possibilities of life beyond Earth, fueling the imaginations that drive real-world exploration. Finally, let's consider the philosophical implications of discovering extraterrestrial life. Such a discovery would not only revolutionize our scientific understanding, but also profoundly impact our cultures and beliefs. It would invite us to reconsider our assumptions about life, intelligence, and consciousness, potentially uniting humanity in a shared quest to understand our place in the vast cosmic tapestry. As we explore these enchanting ideas, allow yourself to drift deeper into contemplation, letting your mind wander through the endless possibilities the universe holds. Each new discovery, each new thought brings us one step closer to unraveling the mysteries that lie beyond our home planet. Let your mind wander as we delve into some lesser-known aspects of our search for extraterrestrial life. Did you know that not all scientists are looking outward for signs of life? Some are investigating what is known as shadow biospheres, right here on Earth. These hypothetical ecosystems could consist of microbial life forms with biochemistries different from those we currently know, suggesting that alien life might already exist alongside us, hidden in plain sight. Consider this intriguing thought. While we often focus on the vastness of space, Some believe that the key to finding extraterrestrial life might lie in the minute nanobacteria. Tiny life forms smaller than typical bacteria have sparked debates about their role in the origins of life. If such minuscule organisms can thrive in extreme conditions on Earth, they might also exist elsewhere in the cosmos, surviving in environments we might otherwise overlook. Here's something that might surprise you. The study of meteorites offers clues about life beyond our planet. Certain meteorites contain complex organic compounds, hinting that the building blocks of life might be common throughout the universe. These ancient space rocks provide a tangible link between our world and the wider cosmos, bringing with them whispers of life's potential beyond our own atmosphere. And did you know, some theories propose that life on Earth might have originated from elsewhere in the universe. This idea, known as panspermia, suggests that life could travel between planets, hitching rides on comets or meteorites. If true, it opens the possibility that life on Earth is not unique, but part of a grand cosmic migration with distant shared origins across the stars. Here's a fascinating fact. Our search for extraterrestrial life is not just about looking for planets similar to Earth. Scientists have also considered the possibility of life existing on super-Earths, planets larger than Earth but smaller than ice giants like Neptune. These planets could have diverse conditions, potentially supporting forms of life vastly different from our own. This leads us to a curious aspect of our quest: the role of artificial intelligence. AI is increasingly used to analyze vast amounts of data from telescopes and satellites, identifying patterns and signals that might otherwise go unnoticed. These advanced algorithms are becoming our partners in the search, tirelessly sifting through the cosmic noise to find the faint whispers of life. Speaking of data, did you know that some of the most promising signals in the search for extraterrestrial intelligence have been picked up by radio telescopes? These dishes scan the skies for signals that might indicate intelligent life, listening for any signs of communication from distant civilizations. Although we have yet to receive a confirmed message, the act of listening itself is an exercise in hope and curiosity. Here's a thought. Water, often called the cradle of life, plays a crucial role in our search. Scientists seek out water worlds, planets or moons with abundant water, as prime candidates for hosting life. The presence of water, whether in oceans or beneath icy surfaces, raises the likelihood of finding life, as it is a critical component for life as we know it. Interestingly, some of the most exciting prospects for extraterrestrial life come from the study of extreme environments on Earth. These places, like the deep ocean vents or the dry valleys of Antarctica, are home to life forms that defy our expectations. By understanding how life thrives under such harsh conditions, scientists can better predict where to find life elsewhere in our solar system and beyond. On a more philosophical note, the search for extraterrestrial life has profound implications for our understanding of consciousness. If we discover intelligent life elsewhere, it might challenge our notions of what it means to be conscious and self-aware, prompting us to redefine intelligence itself. Such a discovery would invite us to broaden our perspectives, fostering a deeper connection with the universe. Reflect on this. Over the years, scientists have also considered the potential of life existing in the atmospheres of gas giants like Jupiter or Saturn. While the surface conditions are inhospitable, the upper layers might provide environments where life could eke out an existence, floating on the winds of these massive planets. And here's a surprising tidbit: the search for life has even reached the field of mathematics. The idea of cosmic music, signals in the form of mathematical patterns, suggests that advanced civilizations might communicate through universal constants or geometric shapes. These mathematical signatures could transcend language barriers, offering a way to connect with intelligences far different from our own. Lastly, ponder the possibility that the universe itself might be teeming with life, but our methods of detection are still too primitive to capture it. The diversity of life forms and the variety of environmental niches in the universe could be beyond our current comprehension, requiring new technologies and paradigms to truly understand. This humbling thought encourages the pursuit of knowledge with an open mind and a willingness to explore the unknown. As you drift into deeper contemplation, allow these ideas to fill your mind with wonder. The universe, with its infinite possibilities, continues to beckon us to explore, learn, and connect with the mysteries that lie beyond our familiar world. As each discovery unfolds, our understanding expands, bringing us ever closer to unraveling the secrets of life beyond Earth. Consider this. The very act of searching for extraterrestrial life has led to unexpected advancements in technology and science. As we refine our methods to detect distant worlds, we also develop better ways to study our own planet. For instance, the tools created to find exoplanets, those planets that orbit stars outside our solar system, have provided vital insights into Earth's climate and weather patterns. It's a beautiful example of how our quest to look outward can also help us understand our immediate surroundings more deeply. Did you know that some scientists are exploring the potential for life under the surface of Mars? While the dusty red planet appears barren and dry on its surface, there are hints that liquid water might exist underground. This subsurface water, protected from the harsh radiation of the sun, could harbor microbial life much like the extremophiles found deep within Earth's own crust. Imagine the possibilities if we were to find even the simplest forms of life there. It would alter our understanding of life's tenacity and adaptability. Let me share something intriguing with you: the concept of a galactic habitable zone. Just as our planet orbits the Sun in a region known as the habitable zone, where conditions might be right for liquid water, there's a similar idea on a grander scale. The galactic habitable zone refers to areas within a galaxy where life might most likely arise. These zones are thought to balance various factors, such as radiation exposure and the availability of essential elements. It's a reminder of the delicate balance that might be necessary for life to flourish on any level. Speaking of elements, have you ever wondered about the role of carbon in the search for life? While carbon-based life forms are all we know, scientists have speculated about the possibility of life forms based on other elements, such as silicon. This is because silicon shares some chemical properties with carbon, offering the potential alternative framework for life. Such considerations open the door to a universe of diverse possibilities, where life might take forms utterly alien to our understanding. Here's an interesting thought. The study of pulsars, those rapidly spinning neutron stars, contributes to our search for extraterrestrial life. These celestial objects emit beams of electromagnetic radiation that sweep across the cosmos like cosmic lighthouses. Their predictable patterns provide a cosmic clock that helps measure vast distances and timescales. They also serve as potential beacons for intelligent life, as advanced civilizations might use them to send signals across the universe. Reflect on this. The search for extraterrestrial life also leads us to question the nature of intelligence itself. As we ponder what forms an alien intelligence might take, we are encouraged to re-evaluate our own definitions and assumptions about intelligence. This introspection can foster a greater appreciation for the diverse expressions of intelligence on Earth, from the social complexity of dolphin pods to the intricate problem-solving skills of octopuses. And here's something that may surprise you. The search for life beyond Earth has reignited interest in the Moon. Once overlooked in favor of more distant worlds, our celestial neighbor has become a subject of renewed curiosity. Scientists are particularly interested in the Moon's polar regions, where ice in permanently shadowed craters might preserve ancient records of the solar system's history. In these icy depths, we may find clues not just to the past of our own planet, but to the broader narrative of life in our solar system. Have you ever considered the possibility of life existing in the outer reaches of our solar system? Places like Enceladus, a moon of Saturn, and Europa, a moon of Jupiter, have captured the imagination of scientists with their icy crusts and hidden oceans. Beneath their frozen surfaces, these moons might host environments where life could potentially thrive, warmed by geothermal activity and shielded from cosmic radiation. This brings to mind the exciting field of astrobiology, a discipline born from the search for life beyond our planet. Astrobiology encompasses a wide range of scientific endeavors, from studying the chemistry of space to developing new technologies for exploring distant worlds. It represents a unique confluence of disciplines, each contributing a piece to the puzzle of life's origins and possibilities. Consider the allure of SETI, the search for extraterrestrial intelligence. It is driven by the tantalizing possibility that we might one day make contact with an alien civilization. This pursuit involves listening for radio signals or looking for optical signals from the stars, any sign that might suggest the presence of an advanced society reaching out across the vast expanse of space. Each signal analyzed, each silence endured, is a reminder of our shared human hope to not be alone. As we draw closer to the idea of potentially discovering extraterrestrial life, there's a beautiful sense of unity that emerges. The search transcends borders and cultures, bringing together scientists, thinkers, and dreamers from around the globe. It is a collective endeavor that speaks to our innate curiosity and our desire to connect with something greater than ourselves. Imagine the profound changes in our worldview that such a discovery would bring. It would redefine our place in the cosmos, prompting us to reconsider everything we know about biology, evolution, and perhaps even spirituality. The mere possibility invites us to be more mindful stewards of our own world, knowing that life, in all its forms, is a rare and precious phenomenon. In the quiet moments of reflection, as you ponder these fascinating insights, let the wonder of the universe fill your thoughts. The stars, planets, and galaxies that stretch across the night sky are more than distant lights. They are reminders of the vast, interconnected web of existence. With each new discovery, our understanding of life and the universe deepens, inviting us to continue the search with open minds and hopeful hearts. Did you ever stop to think about how the search for extraterrestrial life has influenced the development of technology here on Earth? One fascinating aspect is how the need to detect faint signals from distant planets has led to advancements in radio technology and data analysis. These innovations find applications in fields as diverse as medicine and telecommunications, demonstrating how our quest to understand the cosmos can bring unexpected benefits to our daily lives. And here's a curious thought. The idea of panspermia suggests that life might have originated elsewhere in the universe and traveled to Earth on comets or meteorites. This theory implies that life could be more widespread than we imagine, potentially seeding planets across the galaxy with the building blocks of life. Such interstellar journeys, carried out over millions of years, stretch the imagination to envision a cosmos interconnected by threads of life. Consider the intriguing role of extremophiles in our search for life beyond Earth. These hardy organisms thrive in environments once thought inhospitable to life, such as deep ocean vents, acidic lakes, and even radioactive waste. Their resilience has expanded our understanding of where life might exist, guiding scientists to look in places that were previously dismissed as too extreme, both on Earth and potentially on other worlds. Did you know that the discovery of exoplanets has revolutionized our understanding of planetary systems? Planets orbiting stars beyond our solar system come in a dazzling array of sizes, compositions, and orbits. Some of these exoplanets are in the so-called Goldilocks zone, where conditions might be just right for liquid water and, by extension, life. The sheer diversity of these worlds expands the possibilities of finding life in forms and places we have yet to imagine. Speaking of discoveries, the potential for microbial life on Mars remains a tantalizing prospect. While the red planet appears barren and dry today, evidence suggests it once had flowing rivers and lakes. Scientists are exploring whether ancient Martian life might have left behind traces in the planet's soil and rocks. The search for these signs is not just a quest to find life, but also a journey to understand the history of our neighboring planet and its transformations over time. Imagine the impact of finding a techno-signature, a signal or piece of evidence indicating the presence of an advanced civilization. This could be anything from unusual light patterns to radio waves with a distinct structure suggesting artificial origin. The search for techno-signatures is like a cosmic treasure hunt, where each discovery could potentially rewrite our understanding of the universe and our place within it. Here's a surprising fact. The study of space dust can offer clues about the potential for life. Tiny particles traveling through space can contain organic compounds, the building blocks of life. By collecting and analyzing these cosmic travelers, scientists gain insights into how life-sustaining materials might be distributed throughout the universe, possibly even sparking life on distant worlds. Reflect on the idea of the cosmic pluralism, a concept that dates back to ancient philosophies, suggesting that the universe is teeming with life. This belief has inspired thinkers and dreamers for centuries, shaping the way humanity perceives its place in the cosmos. Today, scientific discoveries continue to challenge and expand these age-old ideas, adding layers of complexity and wonder to our understanding of the universe. The exploration of Venus, with its harsh, acidic clouds and surface temperatures hot enough to melt lead, presents another surprising possibility. Some scientists speculate that microbial life could exist in the upper cloud layers, where conditions are more temperate. This notion encourages efforts to study Venus in more detail, searching for signs of life in one of the most extreme environments in our solar system. Did you know that the search for life has also led to unique collaborations between artists and scientists? These partnerships foster creativity and innovation, offering new ways to interpret and communicate the profound questions surrounding the existence of extraterrestrial life. Art and science together can inspire a broader audience to engage with the mysteries of the cosmos. The quest for extraterrestrial life also invites us to ponder the ethics of contacting alien civilizations. If we were to discover intelligent life, what would be the appropriate way to communicate? How would we ensure that our message is respectful and considerate of an entirely unknown culture? These questions remind us of the responsibility we carry as potential ambassadors of Earth. Imagine the excitement of discovering biosignatures, chemical indicators of life, in the atmosphere of a distant planet. These could include gases like oxygen or methane, produced by biological processes. The detection of such gases would provide compelling evidence of life, sparking a cascade of investigations to understand the nature and environment of these alien worlds. And here's something to consider. The field of astrobiology, while focused on life beyond Earth, continually enriches our understanding of life's origins and evolution on our own planet. Each study, whether of ancient Earth environments or extraterrestrial conditions, feeds back into our comprehension of life's resilience and adaptability. Finally, as you ponder these surprising facts, let your thoughts drift to the boundless possibilities that the universe holds. Each fact, each discovery is a step on a journey that invites us to explore the very essence of life. The search for extraterrestrial life is not just about finding others in the cosmos, it's about rediscovering ourselves and our connection to the universe. In this endless pursuit, may we find both answers and inspiration, embracing the mysteries yet to be unveiled.